This is a classic problem, I should say. You see this kind of thing in college algebra. I do harder versions of this problem because I teach you more techniques in that class, and then it's in physics. It's actually a physics application of what we're doing here. The first piece, don't get scared. The first piece everybody should get. If I put this on the test, this part everybody should get because this is just evaluating a function. The only tricky part is explaining the meaning. So you actually have to understand the verbiage in the word problem to interpret the meaning. But the actual analysis and evaluation of h of 3 is not difficult, right? H of 3, how do you do that? Yeah, you plug in 3 for the variable, which is t. So t, what does t represent in this? T seconds. And what is h of t finding for us? The height of the object after it's been launched. So basically what we're talking about here are not rockets. All right, this is not rocket science, thank God. This is projectile science. Okay, because we're launching something, but it doesn't have propulsion. So the moment it leaves, it's out of my control. It's like, that didn't have much propulsion, did it? It didn't go very far. Y'all can't see it on the video, but I'm springing my pen. That once the spring is fully expanded, that's all the force it's going to have. That's as high as it's going to get. It doesn't have propulsion. Other examples of projectiles are things you throw. A rubber band, right? A pencil, an arrow, a paintball. Hopefully you're not shooting bullets up into the air and arrows up into the air. A potato gun. That can still hurt though. You know, anything that is launched but has no propulsion is considered a projectile. So this is an example of a projectile. Let me tell you where some of these numbers come from. This number here is whenever the question is in feet, this number is related to gravity. That's all I'm going to tell you. It's related to gravity. The fact that it's negative and that it's attached to the t squared term, the strongest term in this equation is the squared term, right? Because the t squared term will grow the quickest. Even though you have a 400 on this, eventually this t squared term will be bigger than 400. All right, so this is gravity. Gravity has a negative effect on the object. The 400 actually comes from the velocity, the initial velocity. This is whatever impulse you give the object at the beginning. So 400 feet per second, I don't know, that's like the muzzle velocity of a small caliber pistol or a very tweaked up paintball gun. All right, maybe 400 feet per second. I think, what is it? Anybody do bow hunting? A compound bow doesn't move that quick, right? 400 feet per second is pretty stinking fast. Basically, it's going over a football field in the first second. All right, so that's very fast. All right, now this, I'm not going to tell you what that is. I'm going to save that because you're going to discover it later on. But let's find h of 3. H of 3 will be negative 16 times 3 squared plus 400 times 3 plus 40. And so basically you take your calculator, you're allowed a calculator on this test, and you would evaluate that. One thing you do need to remember is order of operations. Where does order of operations critical here? Yeah, on the squared, you're going to have to do the squared first and then times negative 16. You don't want to do negative 48 squared because then you're going to be way off. You want to do 3 squared is 9. 9 times negative 16 is negative 144. This is 1200. This is 40. And so if I do 1240 minus 144, I get 1096. And oh, what does that mean? 1096. Sorry? Yeah, I started putting the F there. I'm kind of giving it away. So the meaning is after 3 seconds, this object is over 1,000 feet high. Good? All right. H of 0. Go ahead. Yeah. 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 Well, wait. Hold on. Let me just finish this. All right. Equals 40. And Jessica asked, doesn't that mean the object has to be initially started 40 feet off the ground? What indicates to you that it's where it starts? There you go. All right. If you said at 0 seconds it's 40 feet, you're not wrong. But a better way of interpreting that is to say that's how high it started from, right? Because when do you start a clock? At 0, right? Even when they launch the space shuttle, don't they count down from negative seconds? They go T minus 10 seconds or 10 minutes to launch, and then they're like, when they get down to 30, they're like T minus 30, 29, and they're actually counting up to 0, because when you get to 0, what happens? Now the thing is launched off, so at 0 seconds, it hasn't left the launch pad, or it hasn't left the muzzle, or it hasn't left the bow. Okay, so yeah, basically, one of my students just said it's on top of a building. So a picture we could have here is like, you go like this. Here's that. Here's that. Got some bushes. Here's a doorway downstairs. It's a double door. There's some steps. All right. And there's some fella up here, and he's like, woohoo! And he's shooting an arrow or something, okay? And basically, what this is saying is this is 40 feet, okay? So that's how you interpret those. So the meaning, by the way, wasn't that in the original equation? So this is always, the number that's at the end is always the initial height, because when you plug in 0, it's what you're left with. Okay? When you plug in 0, you're left with that, so that must be the initial height. Because at time 0, that's where you're at, or that's where it is at. All right, let me change. Now I'll show you we didn't do any factoring, right? So when does factoring come in? Well, let's say this guy who's shooting this object, the cops come by and they're like, hey, Bill Nye, science guy, you can't be on the roof. You can play with your rocket or your little potato gun, but you can't do it on the roof. So he goes out in the field over there and he repeats his experiment. So now, what would happen if he went out to the field? How would the equation change? The last term would now be 0. Excellent. Does that make sense? Because if you're launching from the ground level is 0. All right, so the last term would be 0, and so you wouldn't even have to include it if you didn't want to. Let me ask you the question now that would involve factoring. Question C. Determine at what time or times the object is 1,600 feet high. Not how high it is. We're trying to find, we know how high it is. We're asking, when does it hit that height? How long does it take to get there? So where do you put that in the equation? There's 2 places it can't go. Let me tell you where it can't go. It can't go in for time because it's not a time. And it can't go in for 0 because it's not the initial height. You can't change the initial conditions on the problem. But you can say, when will this equal 1,600? Does that make sense? And that's how you would actually solve this. Yeah, now I can bring it over and I can solve it by factoring. Now I'm gonna go through this part rapidly just in the interest of time, but again I'm gonna post this later to YouTube. So the rest is factoring. I'm gonna move this over, and this will be negative 1,600 equals 0. And then I want to point out, this has a 16, this has a 16. I don't want to deal with 16 times 16, 2 factors of negative 25600 that add up to 400, right? I don't want to do AC method until maybe I reduce this. So maybe a common factor is 4. I could do 4. I'll do 4 at first. I'm going to do -4 though, just to get rid of the negative. And then when I do, oh wait, if I divide, I have to divide everywhere, right? And by the way, this right here is actually why I can get away with dividing. You normally can't divide out a factor because normally the factor has an x or something in it, right? But when the factor that you're dividing out is just a numerical factor, it has no effect on the final result because this still equals 0, right? Okay, so this will be 4t squared plus, minus 100t plus 400 equals 0. But look at these. These are all still divisible by 4. So let me divide again. Why? Because I wanted to get rid of the negative on my first term. I find it easier to factor if the first term is positive, because then sometimes I can just look at what's left and I can actually see the answer just looking at it. Like this. Do you all see the answer just looking at it? I don't know. 2 factors of 100 that add to -25. If you do 1 and 100, nope. 2 and 50, nope. 4 and 25, nope. 5 and 20, yes, but with a negative. So you're trying to find 2 factors of 100. Positive 100 means the signs are the same. The same as what? The same as b. So all of these would have to be negative. And this is the one that gives that result. And we said when this is 1, you can just skip to the end. Ooh, I really like this. Because somebody asked me a question on a previous problem. And here it is. Here's where it happens. When I set each of these equal to 0, what do I get? I get 2 answers. I get 5 and I get 20. And both answers are positive. On previous word problems, we were throwing out negative answers because they didn't make sense in real life. But we didn't get any negative answers here. We got 2 positive answers. So this is saying it's at a height of 1,600 feet 5 seconds after launch and also 20 seconds after launch. Why does that make sense? Yeah, what goes up must come down. And so as long as 1,600 isn't the highest it gets, it's going to hit that value twice, right? So this is actually what's happening. I'm going to do a time graph down here, and I'm going to do a height graph here, and I'm going to show you what this looks like. It starts at a height of 0. After 5 seconds, it's at a height of 1,600. So now it's here. 5, 10, 15, 20, 25. At 20 seconds, it's again at this height. This tells you so much. Where would it reach its maximum height? Yeah, the point halfway in between these. Does that make sense? Because it takes as much time as it takes to get up, it takes to get down. So if it keeps going up after this, then halfway in the middle, it's going to reach its highest point. Halfway between 5 and 20, let's see, 5 plus 20 divided by 2 will give me the average. 25 divided by 2 is 12.5. So at 12.5 seconds, it'll reach its highest point. Look at, and if it takes 5 seconds to get up to 1,600 feet, how many seconds does it take to get down from 1,600 feet? 5 seconds. So guess when it hits the ground? It would take 25 seconds. The whole flight is 25 seconds. Does that make sense? Because there's symmetry involved here. We didn't launch it off a building. No, gravity slows it down on the way up and speeds it up on the way down, but it has perfect symmetry both ways. Unless something about its flight characteristics changes, like if it opened a parachute or something on the way down, well, that's going to slow it. But as long as it retains the same aerodynamic profile on the way up and the way down, it has the same air resistance going up as it does on the way down. Does that make sense? So there you go. That's the second word problem.